Hi, I'm Miss Hearn. If you like this video, please remember to give it a thumbs up, and you can also hit the subscribe button to see more of my math videos. We're going to be drawing the special angles, pi over 6, pi over 3, pi over 4, in the xy coordinate system in standard position. And a lot of times people don't like them because they're, when we work in radians, because they look like fractions, right? But I want to remind you, to get all the way around the circle, we have to go 2 pi, right? I would like you for a moment to, instead of thinking of it as 2 pi, just think of it as 2. Okay, let's pretend for a moment that to get all the way around the circle, we had to get to 2. Halfway around the circle would be what? Would be 1. And a quarter of the way around the circle would be what? A half, yeah. And what would it be to get to this point right here? It'd be 3, not 3/4. Where would 3/4 be? That's a good question. Or where would 3/4 be? In which quadrant? Quadrant 2, right? Because remember, to get from here to here, we went 1 whole, right? To get halfway, that was at the top. So isn't 3/4 right between a half and 1? Yeah. Okay. Another way to think about that is if this is 1, we can divide that into 4 equal pieces, right? So this would be 1/4. This would be 2/4, which is 1/2. This would be 3/4, and this would be 1. Yes. Let's keep going with that pattern. That was 4/4, by the way. So if I divide the next half of the circle up into fourths, what would the next angle I hit be here? 1 1/4, but how many fourths is that? 5/4, right? Just keep counting. So we had 1/4, 2/4, 3/4, 4/4. Now we're up to 5/4. And then what do we have here? 6/4, which reduces to what? 3/2. Yeah, so that was actually 3/2. And then how many fourths are we at for the next angle? 7/4. And then how many fourths are we at when we get to 2? 8/4, which is 2, right? Okay, so the only difference with radians is that there's a pi in front of each of those numbers, or in back of each of those numbers, actually. So this angle here is 0 pi, or just 0, or it's 2 pi when you get around. This angle here would be what? What if you multiply 1/4 times pi? How do we write that? Pi over 4. What would this angle at the top look like if you multiply 1/2 times pi? Pi over 2. And this angle here, if you multiply 3/4 times pi, is 3 pi over 4. 1 times pi is just pi. 5/4 times pi is 5 pi over 4. 3/2 times pi is 3 pi over 2. This angle is 7 pi over 4, and we're back to 2 pi. So think of it, just ignore the pi, and think of it as you have to get to 2. All right, now this circle, I've just shown you the angles that have a denominator of 4. They're multiples of pi over 4, or multiples of 45 degrees, all of those angles. Let's do one that shows us all the multiples of 30 degrees. Okay, do you remember up here, 30 degrees was pi over 6. You see how the pi over 4s divide the top half, the semicircle, into 4 pieces? So what would the multiples of 30 degrees, or pi over 6, do? You're going to divide it into 6 pieces. So let's draw a circle which are angles that are divide that semicircle on top into 6 pieces. In other words, we're going to have 3 in each quadrant. So we're going to have 1, that's 30 degrees, 60 degrees, I'm a little off, 90 degrees, that one, that one. And then we're going to keep going around and divide the other semicircle into 6 pieces as well. So what I'm saying is this is 30 degrees, this is 60 degrees, this is 90 degrees, this is 120 degrees, this is 150 degrees. What's this one? 180 degrees. This one, 210 degrees, right? 30 more each time. What would the next one be? 240, the next one, 270, the next one, 300, 330, and 360, 30 degrees each time. Now let's do the same thing, but we're going to do it in a radian measure. So I'm going to start with what's 30 degrees equal to again? 30 degrees is 30 pi over 180, which reduces to what? Pi over 6. 30 degrees is pi over 6. So we have pi over 6. Actually, does the pi bother you? Let's just write 1/6 for now. We'll put the pi in a minute. So we're going to go 1/6 of the way to 180, 1/6. And then 2/6. What does 2/6 reduce to? 1/3. And then 3/6. What does 3/6 reduce to? 1/2. And then 4/6. What does 4/6 reduce to? 2/3. 5/6 would be next. That doesn't reduce, it's just 5/6. And what would be next? 1/6/6, which is 1. And then how many 6? 7/6. That doesn't reduce. 8/6 reduces to what? 4/3. Good. How many 6 are next? 9/6, which reduces to what? 3/2. Okay. And then how many 6? 10/6, which reduces to 5/3. Good. And then how many 6? 11/6. And then how many 6? 12/6, which is 2. Okay. Now let's go and put the pi's in. All right. So instead of being 1/6, it's just 1/6 times pi, which is pi over 6. Instead of being 1/3, it's 1/3 times pi, pi over 3. Instead of being 1/2, it's 1/2 times pi, it's pi over 2. At 120 degrees, we have 2 pi over 3. At 150 degrees, we have 5 pi over 6. At 180 degrees, we just have 1 times pi, so pi. 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. So we want to get comfortable with these multiples of 30 degrees or pi over 6 and multiples of 45 degrees of pi over 4. And we want to be able to draw any of the angles that have denominators of 3 or 6 or 4 or 2 actually in the coordinate system pretty easily. So let's practice that.